This is an introduction to Service Mesh. This presentation will cover concepts of Service Mesh, look at open source implementation of Istio and Envoy, offered over Kubernetes cluster.
Let's consider a monolith with single code base, which contains all features of application in single application unit, running as standalone application. When we break it to microservices, each service is an independent service. It can be a single business feature, communicating with each other to perform a business process. Migration to microservices provides huge advantage over monolith by increasing resilience, reducing single point of failure, increase scalability. We can scale individual services as needed, increase flexibility, making a polyglot service and persistence, do faster delivery. Small change can encourage frequent releases, increase business agility. Each team is delivering individual business capability and provide better data security. But microservice migration comes with many challenges. Some of them common cross-cutting concerns are service discovery, load balancing, fault tolerance, distributed tracing, telemetries, security enforcement. Other challenges includes granularity, bounded context, independent releasable, service contract, smart service with dump pipes. We will address most of common cross-cutting concerns using Service Mesh technology and leave other microservices concerts for another day. Introducing Service Mesh. Motivation is do not burden my code with infrastructure-related code, dependency, and decision. Service Mesh mandates to deploy a control tower in its own namespace, which will deploy a sidecar to pods deployed in Kubernetes cluster, which will act as proxy. It will push all the certs for TLS, traffic policies, routing to the sidecar. Sidecar will communicate with other sidecar, will perform all TLS-based service-to-service communication on behalf of the application. Business request will come from external source through gateway, will come to sidecar. Application communicate with sidecar to process business logic, or forward it to another services as needed. As such, sidecar will offload all communication heavy lifting from code to sidecar. Thus, the definition of Service Mesh. A service mesh is a dedicated infrastructure layer that controls service-to-service communication over network. This method enabled a separate part of application to communicate with other services. Service Mesh. Traffic management. Consider a service mesh-based Kubernetes cluster with a control tower and pods with sidecar. We can inject different traffic policy. For example, consider a traffic with header filter of user agent as iPhone imposed on one of the sidecar. This sidecar will process traffic related to iPhone only. Between the sidecars there is TLS traffic which can be of, say, HTTP2 or gRPC type. Application container talk to sidecar which acts as proxy. One important steps can happen is the deployment of a new version of application. That is, a canary version. We can now update the traffic policy, allowing a traffic split of 10% to canary and 90% to current. This will allow to test canary version in live environment, after which traffic can be gradually increased from 10% to 90% in canary and 100% to 0% on current version. We can then undeploy the current version without impacting others. Service Mesh facilitates canary version deployment without requiring to create any major overheads in code and deployment. Benefits of Service Mesh is more apparent when there is a large number of microservices managed by a single control plane and sidecar, without application having to write a single line of code. The whole concept of control plane and sidecar, driving the service-to-service network communication, managing traffic and security policy is what we call Service Mesh. One of the well-known open source project which implements Service Mesh is Istio Envoy.
Istio Service Mesh comes with control plane, which comes with services like Pilot, Galaxy, Istio and Mixer. Data plane consists of normal Kubernetes pod, running an application container. The sidecar, which will be pushed by Istio control plane, is called Envoy. Pilot component of Istio the traffic management and routing, while Galaxy do the config management. It communicates directly to Envoy. The Citadel, or Istio auth, will provide the TLS certs, pushing the credentials to Envoy for secure MTLS network communication between services. Mixer is responsible for policy check, updates and telemetries. It is responsible to consume application and metrics logs, like Jagger, Prometheus logs. External traffic comes from Ingress Gateway, which uses virtual services and destination rules to send the traffic to correct service. These destination rules and virtual services are deployed as CRD system, which is picked up by Gateway. Different security policy can be set on Gateway and Envoy to allow both TLS and non-TLS traffic to pass through. Under permissible policy, both TLS and non-TLS traffic is allowed, while under strict policy, all communication will be converted to MTLS. Application code do not need to know about above traffic and security policy, and will function as normal talking to Envoy, which acts as a proxy for the remote services. Service Mesh, Security Enforcement. NTLS authentication is a way to encrypt traffic using a self-signed certificate. In a typical Istio service mesh-enabled Kubernetes system, we have a control plane and Kubernetes pod hosting application and Envoy container. Control plane connects to Envoy to enforce traffic, security, and destination policies. Traffic will follow Ingress Gateway and will eventually reach the Envoy proxy service. To allow security enforcement, Control plane maintains root certificate as certificate authority. It will sign all TLS certs using this root certificate as root CA. Control plane injects client or terminal SSL certificate to Envoy, while it maintains root certificate authority, which enforces the traffic between Envoy services to use MTLS authentication and is completely encrypted. Authentication mode are injected to Envoy proxy can be strict, allowing only MTLS traffic, or policy can be permissive, allowing both MTLS and plain text traffic. Authentication mode can be enforced with global scope affecting every network communication in Istio environment. Namespace scope affecting traffic in specific namespace and services scope, affecting traffic for specific services. Application do not need to care about network security. It is all taken care by Envoy proxy and Istio control plane. Software market has both open source and proprietary implementation for service mesh. Some open source include Istio, Linkerd, Kuma Community Edition, Apache Service Combo, Network Service Mesh, OpenShift Service Mesh. The proprietary offers includes AWS App Mesh, Console, Kuma, Trafic Mesh, Mjink Service Mesh, Aspen and Gray. According to Digital Journal, the market share for service mesh is expected to increase by 38% in 2028 to approx. 1,411 million. Business Research Insight is predicting an increase to 2,529.8 million by 2028.
There are few disadvantages of service mesh technology. Service mesh adds extra complexity to already complicated Kubernetes communication by introduction of a virtual service and destination rules. If there are large number of policies enforcement, which must be processed for every request, it will add to latency, affecting the performance. Istio data plane hosts the Envoy, while control plane hosts the Istio control tower. Both of these addition require extra compute and memory resources. There is a complex learning curve for Istio gateway and service mesh control plane. Istio proxy acts as middleman within application traffic flows, but it has a reduced visibility by monitoring applications. All major cross-cutting responsibilities of microservices, like service discovery, load balancing, multi-protocol support, fault tolerance, scaling, telemetrics, distributed tracing and security policies are now offloaded to Envoy, which is a sidecar proxy, which is controlled and configured by Istio control plane. Service mesh makes it possible to offload all non-business logic out of microservice into a sidecar, keeping the application container responsible for business-only features and logics. Istio is an open source, is available in GitHub at github.com/istio/istio.git. This concludes my presentation. Please go ahead and try service mesh like Istio and experience how easily your microservices' major cross-cutting concerns are offloaded to the Istio framework. I will have more presentation on hands-on practical use of Istio in coming videos. I thank you all for watching this presentation. Hope you like it.